In this question, we're told that a body of mass 4.4 kilograms is pulled along a rough horizontal table by a horizontal force of magnitude 20, and this is against a constant frictional force of magnitude 14. Given that the body is initially at rest, we're asked to find, firstly, the acceleration of the body. Okay, before we do anything, let's actually get a good force diagram showing everything. So here's the rough horizontal table, and here is going to be the body. It has a mass of 4.4 kilograms, and it's moving in this direction to the right. Let's add some forces. It's being pulled by this 20 Newton force. There's a resistive frictional force of 14 newtons, and naturally we have the weight of 4.4 g and the reaction force from that. Since we're looking for acceleration, we can go ahead and use a motion equation. We can say that the resultant force is going to equal mass times acceleration. So that's F equals ma. Resultant force is 20 minus 14. The mass is 4.4, and we're looking for the acceleration. So 6 equals 4.4a. Rearranging, we can say that a is 6 over 4.4, and that gives us an answer for acceleration, 1.36 meters per second squared. Part B of the question asks us to find the distance traveled by this body in the first 3 seconds. Now that we have the acceleration, we're looking for distance, which is related to displacement. We can use suvat. Let's collect some suvat variables and see where that takes us. We're looking for this displacement. The initial velocity is 0 since it started at rest. Final velocity we don't know. Acceleration we just found. I'll use this fully accurate version, 6 over 4.4. And the time is 3 seconds. We're looking for 3 seconds later. Okay, the formula that links S, U, A, and T is our popular S equals UT plus half AT squared. Let's substitute all of our values in. Since the initial velocity is 0, this first term will be 0. We're adding on half of the acceleration multiplied by 3 squared. So the displacement is simply going to be 27 over 4.4. That gets us 6.14 meters. That will be the displacement in the first 3 seconds. The last bit of the question here has asked us, what is the reaction force? Can we find the reaction force? If we resolve vertically, there are only 2 vertical forces. R, which is in the upwards direction, must equal 4.4 g in the downwards direction. The magnitude of the normal reaction between the body and the table is 4.4 g.